व्यूअर, इस प्लेटफॉर्म पर, इस चैनल पर हम बहुत से टॉप एमएनसीज के प्रोग्रामिंग एंड कोडिंग क्वेश्चंस को डिस्कस करने वाले हैं, जैसे कि गूगल, जैसे कि नेटफ्लिक्स, जैसे कि अडोबी और आज तक की टॉप नॉच जैसे कि अमेजॉन। तो अगर आपको इनमें से किसी भी कंपनी से प्यार है या नहीं भी है, तब भी चैनल को जरूर देखना, क्योंकि यहाँ पर हम हर लेवल के, हर टाइप के, हर एमएनसी के या नॉन एमएनसी के, जो कि इंटरव्यू पॉइंट ऑफ व्यू से काफी जरूरी हैं, उन प्रॉब्लम्स को डिस्कस करने वाले हैं। साथ ही साथ आप जानोगे कि कैसे हर एक वेबसाइट को जुडिशियसली यूज करना है डिफरेंट पर्पसेस के लिए। अगर आप कॉम्पिटिटिव प्रोग्रामिंग कर रहे हो, डिफरेंट वेबसाइट इज मेड फॉर दैट। अगर आप एमएनसीज की तैयारी कर रहे हो, डिफरेंट वेबसाइट इज मेड फॉर दैट। बट इन डिफरेंट वेबसाइट्स के बीच में डिफरेंस कैसे पता करें, इन डिफरेंट वेबसाइट्स को कैसे यूज करना है, किन क्वेश्चन के लिए कौन सी वेबसाइट ज्यादा जरूरी है, ज्यादा अच्छी है, ज्यादा टेस्ट केसेस के साथ है, इन सब की अंडरस्टैंडिंग आपको मिलने वाली है इस चैनल पर। तो अगर आपने चैनल को अब तक सब्सक्राइब नहीं करा है, क्या कर रहे हो, सब्सक्राइब करो एंड हर वीडियो को पूरा देखना और किसी भी वीडियो को मिस मत करना, क्योंकि हर वीडियो के एंड में आपको मिलने वाली है एक बोनस टिप, जो कि बहुत ज्यादा हेल्पफुल होगी आप सबके लिए। वेदर आप टेक्निकल रोल्स के लिए अप्लाई करो, वेदर नॉन टेक्निकल के लिए अप्लाई करो, क्योंकि ये जनरल प्लस प्रोग्रामिंग के भी टिप्स होंगे, कैसे एक प्रॉब्लम को या कैसे इंटरव्यू में आपको बिहेव करना चाहिए। तो अगर आपने अब तक नहीं सब्सक्राइब करा, सब्सक्राइब जरूर कर लेना। एंड अब टाइम वेस्ट करे बिना आज के कोडिंग क्वेश्चन की तरफ चलते हैं। आज हम क्या नया देखने वाले हैं और आज की बोनस टिप आपको क्या मिलने वाली है। तो चलो विदाउट एनी टाइम वेस्ट आज के कोडिंग क्वेश्चन की तरफ चलते हैं। हेलो एवरीवन, सो वेलकम बैक टू प्रोग्रामिंग वर्ल्ड चैनल बाय मुस्कान गुप्ता। आज का क्वेश्चन जो आया है सीधा इंटरनेशनल प्लेटफॉर्म से, हमारे इंटरनेशनल, दैट इज reorder routes to make all paths lead to city 0. रूट्स दे रखे हैं हमको, लेट्स से ये 2 पॉइंट्स हैं, लेट्स से 1 and 2, and this path is valid. Okay, so this is given like this and this is a route. Okay, and if there are multiple, let's say 3 is coming like this, so then we have here 3, 2 and like this. So we are given with an array of this. Reorder routes to make all paths leads to city 0. This is today's POTD streak question on Leetcode. You can check it out on your platform through your ID. The relevance of this question, first let's discuss that, and then we'll go to the exact problem statement of this question, what it is asking on the Leetcode website, because it was really lengthy, so I thought I will explain it through the website itself. So here the relevance of this question is, this question has been multiple times asked. In past 1 year it has been asked more than 20 plus times. Okay, it has been asked more than 20 plus times, and this question was throughout the video interview. So this question has been asked in the video interviews or the interviews that are of 1 hour or 2 hour as the main question. So if you get this question, you can definitely expect that you will land up a job in that organization. Okay, so now this is today's question. This was the relevance. So let's discuss what this question is saying about and what this is. This is a medium level problem, 1466. There are n cities numbered 0 to n-1, where n-1 roads are there and there is only one way to travel between the two different cities. Okay, let's say if this is a city, then I can go either this way, and if these are the city and the route is defined like this, then I can go only this way. So it means that it is not two-way. Okay, it is directed. It is a directed road, or you can say one-way road. Last year the Ministry of Transport decided to orient the roads in one direction because they are too narrow. Roads are represented by the connections, where connections AI and BI represent a road from city AI to BI. Okay, so let's say 1 and 2. So this here, these are what the two different elements. This year there will be the big event in the capital city 0, and many people want to travel to this city. Your task is to reorient some of the roads so that each city can visit the city 0. Return the minimum number of edges changed. It is guaranteed that each city can reach city 0 after reorder. This is the significance of these type of questions. So by reading this statement, can you infer that this question or this statement is so much relatable to our real life scenarios? That's why the programming is so much important, and the understanding of data structures and algorithm is getting so much importance because of this. Because if you are clear with these things, you're able to solve these questions. And this question I can completely relate. So there are like different number of cities, and you need to change the order of the city or order of the road. Okay, if this is this way, I need to do it this way. Okay, sufficient amount of energy and amount will be required for this conversion, that's for sure. So we definitely wants to minimize this conversion. We won't want ki whatever the road is coming in our way, we just change the direction. We want to minimize the cost, and this is what this actually is signifying, or this question is being asked. So I can completely relate like with the real life scenario. That's why programming and everything is getting so much hype, so much importance, because many of the real world problems can be solved through this if you are a good problem solver. And this is what this question is asking about. Let's understand this better with an example. So here's an example where this is the road going this way, and then it's coming back. Okay, then this is coming back, but this is going the other way. So now in any case, this is the city 0 where I need all of the roads to meet. Okay, so this is my end requirement. Now through any of these, like in this case it doesn't matter, you need to change this direction. Okay, but there are certain cases, or there will be certain test cases in which you have to figure out what is the minimum change. Here in any of the case, through any of the path, if you go, the change will be 3 only, because this is connected just once. But let's suppose there is one city which is like 6, and that's connected to 1 like this, and now I have to change, and that is connected to 0 as well, but it's like this. So now if I have to make a decision with respect to this, then the results could vary. Okay, but here in this scenario, or the example that they had used, is pretty straightforward. So in any of the case, through any of the ways, if you go on, there will be this 2 changes that will be required, and there will be this 1 change that will be required. So the total number of changes will require to be 3. That's why the output is 3. Change the direction of edges shown in the red such that each node can reach node 0, which is the capital city. Okay, similarly, let's understand this with the second example. So let me clear the screen first. Yeah. So here n is equals to 5. 5 nodes are positioned like this. So in any of the case, now this is a straight line basically. There are no more connections related to that. So in any of the case, like I need to change the direction of this and change the direction of this. So the minimum changes or the required changes, both required changes and minimum changes, are 2. Then n is equals 3, where 1 0 and 2 0. Okay, n is equals to 3, 1 0 2 0. What does that signifies? 1 0 and 2 0. It means both of them already are meeting at city 0. So there is no need to change, or there are no moves that will be required. That's why we'll return the answer 0. Okay, so this was the understanding of the question, and I hope that you understood the question, what it is asking and what we need to return. If you have any of the doubt, do mention in the comment section. And now through this we can also infer that this question basically, so first identify the data structure that we will be using to solve this. The data structure, definitely by seeing this and everything, the data structure comes out to be graph with like eyes closed. Whenever there are questions of routes, minimum thing, maximum thing, minimum changes required, etc., eyes closed, the answer is graph. You don't need to give a second thought related to it. Okay, so firstly the data structure that we'll use is graph. But the main, I should say the main point to think here is that how to use this graph, how we can construct basically a matrix or an list through which we can iterate through the through all of these nodes. Okay, and when first the second thing, so first thing was identifying the data structure. Second thing is identifying the algorithm to use. So if it is graph, if the data structure is clear, algorithms are minimized. So let's say algorithm is a big umbrella. So no. Algorithm is a clear sky. But when you have decided that it is like the data structure, then you have an umbrella. Now you need to choose just inside that umbrella. So here the graph. So what are all the algorithms that are available in graph? These are DFS, BFS, then minimum spanning tree algorithms are there, and one more type is UF, which is union and find algorithm. So these are specific algorithms. In minimum spanning tree there are some Kruskal's and all the other algorithms, but we don't want to discuss those basically. So these come under the umbrella of MST. So DFS, BFS, MST, and union and find. So these are the graph algorithms. So second, we want to choose any of the algorithm which we can use to basically iterate over this graph and compute the result. Okay, so now first and the foremost thing is, when we know that all of these data structures and algorithms like work almost equally, then on what matter or on what parameters we should do or specify our judgment. So if I'm choosing DFS, what should be the parameters to choose DFS? And if I'm choosing BFS, then what would be the parameters on BFS? Okay, both take same time complexity. So now the question arises on space complexity. Okay, if the DFS uses like the less space, then I will definitely prefer DFS over it. If BFS uses like less space, then I will prefer BFS over it. But in this case, it doesn't matter because this is the array that is given to us. In any of the case, in any of the algorithm, DFS, BFS or union and find or MST, we need to construct a data structure in a way that it can properly serve as a graph. Okay, so we need to construct that. These nodes that are given to us are not graphs, firstly, because these things doesn't tells us about the edges. Okay, like in which direction the edge is going up. So this detail is missing here. Also, this specific, like just this, cannot serve as a graph. That's the main thing. Okay, so we need to construct. So on that basis, if we have to construct a DS or we have to use some space, then it doesn't matter that which algorithm we use, because every algorithm has same time complexity and the space complexity will also be same. So here in this video, we will be using the DFS. You can choose whatever algorithm you are comfortable in, but we will be discussing the DFS approach and I'll be explaining that. And you can implement, like if you are clear with the DFS approach or the BFS approach, or you know that thing, you can just implement that basically. Okay, but I'll be implementing DFS, but the data structure or the space array which we will be constructing will be the same in all of the cases. So now it depends on algorithms. I am using DFS, you can use BFS or you can use U and F as well. That totally and is completely fine. Any of the algorithm we can use to that. Okay, so now firstly, let's discuss about the data structure or the type of data structure. So here the first thing will be that there will be a vector where I'll be pushing, let's say my edge is going 0 to where it is going 1, and is the edge directed like this way or this way? So this way it is. So if it is this way, I will mark it as 0. This is my, let's say, direction of edge, like where my edge is pointing. If it is this way, it is 0, and then we will construct one more thing, which is 1, 0, like the edge over this, and this will be 1. So this is how we will construct the graph. Similarly, 1, 3, 0, 3, 1, 1, and same case. So that will be 3, 2, and this is coming opposite side, right? So it will be 1 and then 2, 3, 0. So this is how our graph will be constructed. Using these values 0 or 1, we'll check whether we need to change the edge or not. Okay. And then let's say I'm at this node. So I will visit all of its adjacent nodes, which is 1 and 4. I'll go at 1, make it as current node, and then visit to its adjacent node, and we'll see whether it is pointing this way or that way. If it is pointing this way, firstly I'll mark it as it as visited is equals true. If it is going to this way, I will change its direction and will update it into a variable, let's say count, which was initially 0. I'll do it +1, like this edge will be changed, and then I'll visit this node, and then again we'll check like that. So here if this is also again in the opposite direction, so I will change that and will update this. This is also v is equals true now, and this was already in this direction, so that is true. Now I'll go here, I'll go this way, so this was in this direction, which we are signifying it signifying it through the value 1. So if it is already 1 when we have inserted it, no problem. If it is opposite side, then we'll change it and then we'll increment the count. This is the whole idea, and this is the whole data structure behind this, or what we will be using. If you have any doubt, if you are not like able to cope up with that, or if you have any doubt with respect to like explanation, do mention and drop it in the comment section, and I'll definitely look it out and respond to that as soon as possible. So guys, I hope the explanation part is clear to you. So now let's proceed to the coding part, the most exciting part of the video. तो अगर नहीं समझ आया है, कोई भी डाउट है, do mention in the comment section and I'll look into that and respond to that as soon as possible. And let's start the coding. So firstly, we'll consider an let's say agency list of size n, where the connections are given to us, which will be how much? 0 to n minus 1, which will be the number of nodes basically. And then we'll construct this, which is nothing but the connections, and then I'm pushing this agency list connection 0 dot push back, and what I'll make pair is connection 1 comma 1, which is like the edge is coming straight, and when I'm doing it on the other side, then it will be 0, which we discussed that this is how we'll construct the matrix. Now this will be constructed. I'll pass initially, which is like the initial node, which is to 0, and then the variable value, which will be -1, and then this. Here I'll initialize this variable and will define this function void dfs, which is nothing but int node. Initial parent will be nothing, so that's why I have passed it -1, and then we'll basically do this. So I'll just copy paste it here and we'll define this. Now I'll run a loop for auto, and we will be doing it by reference. Why I am doing it with the reference? Because if we are not using it by reference, then it will be creating every time a new copy. New copy will lose the sign or lose the trace of what has happened already, which we don't want. That's why we are passing and using everywhere like a reference, because if something is changed, then I want to know that this thing is changed. It shouldn't be like first iteration I have changed it, but in the next iteration I'm not able to find it. Okay, and then so here if child is not equals to parent, then we will increase the count, and then again we have passed this child node and agency matrix. Here the main point to notice is, if in the code you just forget this reference operator, then you won't be able to get your answer correct. This is the main, I should say, the catch in all of these algorithms, because I have done that mistake many times. That's why I can tell you that do not forget this thing, otherwise you will be like परेशान होते रहोगे where I'm going wrong and there will be nothing going wrong, it's just that you forgot something. Okay, just a bit thing. So here the golden coin swapped. The efficiency of this algorithm is 84.1. The memory of this algorithm is coming out to be the space complexity 67.9. Let's run it again, see if it is increased or decreases the time complexity. And it increases, and that's 97.25, and space complexity is also increased, which is not bad. So अगर इसमें काउंट करें ऊपर से, so 10 on 10 guys, it's like तुमने इंटरव्यू पार कर लिया और जॉब तुम्हारे हाथ में आ गई. अदरवाइज अगर जॉब मतलब वो फाइनल राउंड नहीं है तो तुमने एटलीस्ट वो इंटरव्यू का राउंड क्लियर कर लिया. सो पैट ऑन योर बैग्स, वी हैव सॉल्व दिस क्वेश्चन with the best approach. This is what this signifies, that the approach was best. And बढ़िया से हो गया. तो अब इंटरव्यू में अगर दिखे ये क्वेश्चन तो अब तुमको पता है कि इसे कैसे सॉल्व करना है. So if you like today's video, today's question explanation, then do not forget to like, share and subscribe the channel. Share it with your friends guys, as sharing education is really a good deed. And do not forget to press the bell icon so that you will be notified whenever I post a new video. And we'll meet in the next video. Till then, stay safe, stay healthy. Bye bye. Love you all guys.